Good afternoon. My name is Jacob Rapararani. I'm a UNISA student number 466-79901. I'll be here taking you through the project presentation for transportation. So basically, the project that I will be presenting, it's all about upgrading of a 2.2 kilometer road on road R333. The road is in Vaalwater town. So on my next slide, I'm having the discussion topic. So the topics that are on this project, I'm having an introduction, project description, brief project description. I'm having survey, pavement design, drainage, and conclusion. So those are the elements that I'll be presenting on my presentation slide. Starting with the introduction, the project aim. So this project, it entails upgrading of a section 13 on road 3 R33 is from 60.8 kilometer to 63.0 kilometer. So the difference of it, they makes 2.2 kilometer in Vaalwater town. So the Vaalwater town is in Limpopo province, and then on that road upgrade, it's all about it's a 4-lane divided road, and then furthermore we've got the sidewalks. So on my next point is the realignment of road to improve the substandard curves and to provide the drainage system. Surely, the road and the water is an enemy when it comes to roads. So the road drainages, they are very much important. So they will be indicated on my project. Uh, I'll be going to the project description. Like I indicated, when it comes to the project location, the road is located within Waterberg district, and then it's under Molle Mokgopong local municipality. So what I'm having there is a locality map or indicating where exactly the road is. So it's the one that is marked in yellow on my presentation. The next slide is all about topography of there. So the topography is indicated that the Vaalwater area is a mountainous area of Waterberg from all large plateau, steep escarpments to the south and east. So the area receives between 650 and 900 millimeter rainfall annually. So the next slide is talking about the traffic information. A traffic count was conducted as road is an access road providing an access to the local residents. So the reasonable assumption will be adhered and a 4% growth rate will be used on this traffic information. This will sufficient to determine the class and the pavement layer design for the proposed design life. So the design speed, so we are having the table on our TRH 7.5, so it's indicating the design speed of 60 kilometers per hour. So it will be the one that it will be recommended. So that is what we'll be going to designing our route for. And then the stopping site distance is between the 60 kilometers and 80 kilometers was adopted. So we are having the table 7.5 indicating, the design speed and the stopping site distance in terms of the meter distance. The next slide is talking about the horizontal alignment. Since the existing earth tract consists of substandard horizontal curve to improve the road user safe as well as maintenance safety level economic for the project, the following restrictions were adhered to. On the horizontal alignment, I'm having the minimum distance of horizontal curve is a 40 meter. Furthermore, I'm having minimum curve of radius is 25 meter. I'm having the minimum distance between two consecutive curves is 14 meters, and the minimum design speed is a 30 kilometers per hour. So the horizontal alignment is greater than 250-meter distance and less than 110 meter. So the curve of radius for this given speed, it will be 60 kilometers per hour is adequate. Vertical alignment. So we are done with the horizontal alignment. So now we are moving to the vertical alignment. Since the terrain of topography was classified as mountainous and a rolling, and to ensure adequate sight distance throughout the full length of the road, as well as to maintain the satisfactory level of economic for the project, the following restrictions will be adhered to. So we are having maximum gradient of 16%, and then the minimum gradient, it will be 0.5%, and then the minimum vertical curve length is 100 meters. So the minimum K value there, we are having it as 4. So continuing on the slide for the vertical curve, there we are having a point whereby it's just is to illustrate that the curve length is 60. We multiply it by 2, giving us 32 meters, and then 32 meters is less than 373.936 meters. So the length is adequate. So we will be moving to the slide talking about the pavement structure and the surface design. So the pavement structure is given as 40 and a wearing course of 150 millimeter G2 base layer and a 200 millimeter C4 sub base will be adequate. And furthermore, when it comes to the subgrade design, the road section can be assumed to be uniform with an average CBR of 15.5% and then a standard deviation of 1.06. So the road category is in TRH4. It will be the road classification of B. And then when it comes to the subgrade layer, will be tested and reworked to mitigate against the base failure and erosions. So this will be required regularly to maintain in order to ensure the longevity of the surface. So, after the road, talking about the pavement structure, we will be moving to the drainage system. So, as the first point bullet here is just indicated that the Limpopo Department of Transport Road Drainage Manual was utilized. So, the drainage design standard utilized were as the following. So, the minimum culverts diameter that will be used, they will be ranging from 600 millimeter and 900 millimeters. So those will be the different diameter of the culverts that will be used at the low point, and 300 millimeter between 300 and 450 diameter pipes to be used on the channel drainage with the intersections at the area within the flat nature of the terrain. So furthermore, we are having a minimum velocity of 0.33 meters per second. And then on our maximum velocity, we are having 4.0 meters per second. Scoring at the outfall parts are limited with a concrete slab. The rhino mattresses and gabion basket will be used. And then if there are any wetlands and the existing with the Limpopo Department of Transport road drainage, a manual was utilized. So those are the indications talking about the drainage system that will be used, on will be part of the road upgrade of the roads of 3R333. So I will be moving to our conclusions or our conclusion. So on our conclusion, we're having the main aim of this design was to provide the suitable vehicle movement facility for the community living adjacent to the R333. And then furthermore, it has been provided its durability over time, and it will be fit for, for the community to can use the road. So those are my conclusion for the project report. So in a nutshell, my representation will be ending there. So I would like to thank you for the presentation of this project report for the transportations. I thank you.